driving you crazy, or if you're finally admitting you're lazy and your test grades have been dropping, it's time to get your arrows popping. Hello everybody. This is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about 8th grade mathematics, the final exam review, part 2. What's going on, Tamaya? Tamaya's in the house already. Let's go ahead and get our chat up so we can see what's going on with the world out there. And we are going to be looking at part 2 once again of the 8th grade end of course second semester final exam review, getting everybody ready for their finals. What's going on, Fabiola? Good morning to you. How's everybody doing there? Sorry I got on a little bit late today, guys, but that's how things go. That's how things go sometimes. That's right. But I am ready for you guys. I have some good problems to show you guys today for us to work on and for our 8th grade students to get prepared for their final exam with. All right. Well, let's go ahead and get things underway, especially since Fabiola is here now and Tamaya. Okay. It says in problem number 23, order the following numbers from least to greatest. Well, we are given 8 and 3/8. We're given 8 and 2500ths. We're given 3 pi, and we're also given the square root of 67. So you have a choice. You can compare all of these values as they are, or you can change them all into mixed numbers. You could do that. You could try at least. You could make them all into decimals, yeah, or approximations, correct? Or you could already have an already known knowledge of the values of these numbers. Okay, so you can go in there with preconceived notions of what these values are worth. However, I'm going to go in this with the exact values. Okay, so what's going on? So we're going to go ahead and change each of these values into an approximation in their decimal notation in order to compare them. All right, for instance, if I'm looking at 8 and 3/8, all right, and let's go ahead and change this ink here, then I know that I can convert this into decimal notation by converting the denominator into a power of 10. What do I mean by that? I mean that the denominator 8 can become a power of 10. More specifically, it can become 1,000. Yeah, exactly. So what's going on, Eric? How are you doing there? So Eric says, Mr. Ritt, you rock. I want to thank you for helping me get through my 0312 final last week. My pleasure, Eric. Good job getting through that final. In order to get 8 to become 1,000, we had to multiply it by 125. So if I multiply the numerator by 125, we'll get 8 and 375 thousandths. Therefore, the value of the first number in decimal notation is going to be 8 and 375 thousandths. Yeah, exactly. Now we have something to compare alongside the second value that was given to us, which is the 8 and 2500ths. So we'll leave this exactly as it is because now we have confirmation that the first value is larger than the second value. Then let's move on to 3 pi. With 3 pi, guys, we have 3 times the approximation of pi, and we'll go ahead and use that common approximation in decimal notation. That is 3. Can I change these colors to exactly what I want? There we go. I want it black. Thanks. All right. We're going to change this into 3 times 3 and 1400ths. Okay, so that's where we want to go with that. Chosen Creeper is in the house. How's it going, Chosen Creeper? And now just multiplying the approximation for pi, the 3 and 1400ths times 3. I don't know what this is. We're going to go ahead and multiply it out, though. We're going to multiply this out. We got a 12. We're going to curl a 1. We got a 4. Then we got a 9 with the decimal. There we go. We got the 9 and 4200ths. There you go. All right. So far, so good, right? We are already looking at 3 values from our list of 4 values that are now in decimal notation. Chosen Creeper says, I really wish to watch the whole stream, but I'll catch it next time. No problem, Chosen Creeper. It'll be uploaded on the channel and you can check it out there. All right. And so finally, Our challenge is to find the approximation in decimal notation for the square root of 67. Adane says, Mr. Wood, you're an amazing person and great teacher. Thank you so much, Adane. I am doing the best that I can to share my gift with the world. That is exactly what's going on. And so far, guys, we have our 8 3/8, which is exactly, not even an approximation, it's exactly 8 375 thousandths. We know that our 8 2500ths is exactly as is given to us. We know that 3 pi is approximately 9 4200ths, and now we're going to find out the value for the square root of 67. So let's go ahead and go to the next page in order to make that happen. And what we're going to use, guys, is we're going to use the estimate of the square root of 67. We're going to convert this into an approximation in decimal notation. So what we are given is we're given the square root of 67. And our nearest friends here, okay, our nearest perfect squares would be the square root of 64 as well as the square root of 81. The reason why we're using these perfect squares here is because we are already aware of their values. For instance, we know that the square root of 64 is 8, right? We know that the square root of 81 is 9. However, we may not know exactly what the square root of 67 is. Well, that's why I have this formula above here that'll help me generate the exact approximation to the nearest tenth of the square root of 67 so that we can compare it with the other values that we're given already. All right. So what we do know is that our A value, according to this expression here, our A value would be 8 because we already know that the square root of 64 is 8, right? Okay. And we know that our B value is going to be 9. Exactly, because we know the square root of 81 is 9. So that's going to be our B value there. So what we're trying to find out is this C value, exactly what it would be. And thus far, we know that it will be 8 plus some fraction, okay, as far as our approximation is concerned. So how do we get there? We're going to start out by saying that our C value that we're looking for will be equivalent to 8 plus C squared, which in this case is 67, minus our A squared, which is 64, divided by B squared, which is going to be 81, minus our A squared again, which is going to be 64. All right, and we'll be simplifying this. So we'll end up with 8 plus 67 minus 64 is 3, divided by 81 minus 64. What is that? What is this? What is this value? Do I even know what this is? Let's figure this out. There we go. It's 17. All right, so what we're looking at is already a value as a mixed number that is 8 3/17. Good stuff. So what's going on, Ajib? Let's go ahead and continue now, guys. So what we need now is the decimal approximation for the 3/17. So we'll have 17 going into 3. Let's see what that looks like. And we know that 17 won't go into 3, but it'll go into 30 once. Then you'll subtract. You'll bring down the 1, the 3, and the 0 here. And we'll have 17 going into 130. I believe it's going to be 7 times, guys. So let's go ahead and check that out. Let's see, 17 times 7. That gives us 49. No. 49. There we go. Give me 4. All right, 49. Then we got 119. Yeah. So there we go. So with this approximation and rounded to the nearest tenths place, if we know that the 3/17 is approximately 1700ths and we already have our 8, then that means that this value is going to be approximately 8 2/10. And this is the value that we'll be using to compare our values. Okay, so let's go back to where we were. We thus far have 8 3/8, which is going to be 8 375 thousandths. We know that our 8 2500ths is already in decimal notation. The 3 pi is 9 4200ths as an approximation. And our square root of 67 we just found is going to be approximately 8 2/10. So in arranging these values, we'll say that the first value from least to greatest is going to be our square root of 67. That's going to be the first one we need. Then from there, we'll have our 8 2500ths. Then we know that the 8 3/8 would come next. And then finally, you'll have the 3 pi, which has the largest value. And we're going to red box it. That's right. Red boxing it. And that's how we are putting these values, these real numbers, in ascending order from least to greatest. All right, so if you guys need more practice changing irrational numbers into approximations to the nearest tenth, check out the video that's on our YouTube channel called Estimating Square Roots to the Nearest Tenth. There you go. But that's the formula that's used in that video right here. There you go. That is the formula. That's the process that is used in order to find out the square roots to the nearest tenth. Amen. Amen. For number 24, guys, they ask us to write an equation that best describes the relationship between x and y in the table. So notice that we have our input values, our x values here. We have our y values, the output values. Yes, we do. And one of the values that they gave us is the y-intercept. I know it's the y-intercept because the format of a y-intercept is the x value must be 0, and then you have the y value be whatever it needs to be. So they're giving us the y-intercept already. So if I were referring to the slope-intercept form, which is y equals mx plus b, where in this slope-intercept form, the m value describes the slope, whereas the b value describes the y-intercept, then they already have given me my b value. The b value is 3. There it is. So Fabiola says, I need to practice that approximation. Looks really easy, but I need to practice it. Absolutely, Fabiola. Everything will be easier in time with practice. Absolutely. So check that out. Yeah. But it comes in handy, as you already see. It definitely comes in handy as far as being able to approximate the irrational number to the nearest tenth using that process. All right, so continuing on, what we don't have in this problem is the slope. So we'll be using the points that from this table. We can use these points, 2 of them, to find out what the slope of the line is. Okay, so that's what we're going to do. So we're assuming that this is a linear function here, okay, we can find out what the slope is. Amen, amen. So the slope formula is y2 minus y1 divided by x2 minus x1. And assuming that my first point that I'm going to use is 0, 3, and the second point being 8, 5, let's plug in these values. The second y value that I'll be using is 5, minus the first y value, which is 3, divided by my x2 value, which is 8, minus my x1 value, which happens to be 0. So simplifying this, you'll have 5 minus 3, which is 2, divided by my 8, and then simplifying this value by 2, we'll end up with a slope of 1/4. That's right. What's going on, Stephen Chong? And Lewis coming in with the link. Thank you so much. So what we'll do now with this is go ahead and plug in our slope as well as the y-intercept into the slope-intercept form. So we're going to use these values, one that was given to us and the other that we generated, into the slope-intercept form to get our answer in slope-intercept form. Amen, amen. So you'll end up with y equals 1/4 x plus 3 and done. There it is. Yeah, that's what's up, guys. So we end up with our solution in slope-intercept form. This is an equation that best describes the relationship between x and y in the table. Done and done. Oh, yeah. Let's go ahead and red box this answer right here. Yeah, there you go. That is problem number 24, and we are moving on. Guys, if you could, just go ahead and feel free to share the stream on your social media. Also, thank you, Lewis, with the slope formula link there in the chat. Appreciate that. Let's go ahead and get that up. And once you have shared it with your people that you know, that you love, go ahead and share with the people that you hate. There you go. Give them a little love this Saturday as well. And also like the video, subscribe to Fort Bend Tutoring, and click that bell icon to let you know, to get notified when we're live with new, fresh content. In problem number 25, it says, what is the equation of the line shown in the graph? Let's go ahead and get a look at this line. There we have it. Yeah, in Christmas colors. There you go. Green and red. Just saying. So that being the case, Let's start out by putting this, preferably with my choice, thank you, slope-intercept form. I like slope-intercept form. I mean, I'm aware of the point-slope form, yes. I'm quite aware of the standard form of a linear equation, oh yeah. But slope-intercept form is what I'm fond of. Just saying, we have history, okay? We go way back. You can even say that. With a wiffle ball bat. Thank you. I just made it up on the fly, as you hear. Let's go ahead and start with the fact that we have our y-intercept showing right now. And the y-intercept is clearly, if that's clear to you, it's clearly -2. Thank you. That the y-intercept is at -2, that the line is crossing the y-axis at -2. So therefore, this value right here, I can use as my b value. This is a B. Yeah, I know it doesn't look like a B. I'm going to fix it. It's quite ugly. I understand that. I'll be fixing this B now. Thank you. It's a better B for you because I needed you to have that best B. Thanks. Now for the slope. The slope we know from the graph to be the rise divided by the run. So the ratio of the rise divided by the run, any 2 points on our line, we can generate the slope from that using the form rise over run. So if I say, for instance, that I start at this first point here, that's in red. If I go down 2 places, okay, and then over 3 places to the right, I would end up with a rise of -2 and a run of +3. I have a -2 for my rise because I started at this higher point and had to go down to get on the same level as the second point. And then I had to move to the right. So that's a positive move, moving from left to right. So that being the case, we have a slope of -2/3 now. So that means that the y-intercept is -2, that the slope is -2/3. So my equation can be written as y equals -2/3 x minus 2 and done. That's it. It's over now. Yeah, we're going to put a red box around this. Red boxing it for the equation of the line shown in this graph. Amen, amen. Thanks, Lewis, once again for the links. That's right. And there's Tamaya with the link to part 1 of the 8th grade mathematics final exam review. So we're moving on to problem number 26, guys. Problem number 26. Here we have some angles showing. They want us to solve for x when the measure of the angle of LKM. Let's go ahead and map this out. LKM. So this larger angle here is equivalent to 90 degrees. We also know that from the symbol, all right, that's given to us on the diagram. This square symbol here confirms also that we have a 90-degree angle. So what we are looking at is we're looking at 2 smaller angles that are complementary. Complementary angles, guys, add to 90 degrees. Oh, yeah, they add to 90 degrees. So because we know that these 2 angles add to 90 degrees, we can create an equation to solve for x, because the sum of these 2 angles must equal the value of the larger angle, which is 90 degrees. So set your equation up as 3x plus 10 plus 2x minus 5. And this, I hate the minus sign. I hated the minus sign, so I'm fixing it. Thank you. The minus sign had to go because it was ugly. Thank you. It had to leave. It had to leave us in peace. Thank you. So now, let's combine our like terms. So combining our like terms, we have 3x plus 2x. That gives you 5x. We have 10 minus 5. That's going to be 5, right? And this equals to 90. From here, we'll be isolating the term with the variable, so we'll be subtracting 5 to both sides using the subtraction property of equality. I now have 5x, which equals to 85. Oh, yes, I do. And then I'll be dividing both sides by 5. And so we end up with x equaling 17, guys. 17, and there it is. Good stuff. All right, Tamaya, go ahead and get that breakfast that you need there. And we will be red boxing it. Done and done. So because we realized that we had complementary angles, and also because of the angle sum property there, that the 2 angles within the 2 smaller angles had to combine, had to add, the sum of them had to equal to the 90 degrees of the larger angle that we were given. Oh yeah, that's exactly what happened. So this is problem number 26, and we are moving on together. There you go. with problem number 27. What's going on, Raul? How you doing? Hello, sir. Glad to be back again, and I'm glad you're here too, Raul. I am. There you go. I have a smile on my face, sir. Thank you, because you're here, and I appreciate that. With problem number 27, we have a linear equation that they're asking us to solve for the variable. That's right. So with this equation here, we have negative 4 times the quantity of negative 3x plus 5 equals 30 plus 2x. If you guys know me well, you should know I'm about to get my arrows popping. Thank you so much. Let's go ahead and show that to the people. There you go. We have our arrows popping. Thank you very much. And the negative 4 times negative 3x is going to give me a positive 12x. Oh, yes, it will. The negative 4 times 5 is negative 20. Thank you. Appreciate that. Bring down the right side, which is 30 plus 2x. And now, that's right, Raul is already coming in with the answer. Then we're going to be isolating those terms that have the variable by subtracting 2x to both sides of the equal sign. You want to get all the terms with your variable on one side of the equal sign. That's what I'm doing in this step right here. We have 12x minus 2x. That gives me 10x. Minus 20 equals 30. And now, my next step in isolating the term with the variable, guys, is adding 20 to both sides of the equal sign. That's exactly what I'm going to do. So bringing down my 10x equals to 50, and then go ahead and divide both sides by 10. Oh, you will end up with x equals to 5, and that is exactly what Raul had. Good job, Raul. I'm going to put my answer in a red box, sir. Red boxing it with problem number 27. Yeah. That was exciting for me. Thank you. Fabiola's in the house with the correct answer. Good job, Fabiola. Great job, lady. Way to go. And we are moving on to problem number 28. Yeah, that's what we're doing. We're keeping things moving today. Thank you. So this is problem number 28. And in problem 28, it says to label each as a rational or irrational number. Well, guys, as far as rational and irrational numbers are concerned, you have a rational number anytime you can put it in the form of A divided by B, where A and B are integers. So anytime you can rewrite the number as the ratio or quotient of two integers, then you have a rational number. And if you can't, you have what is called an irrational number. So let's go ahead and set up two columns here. We're going to set up a column for the rational numbers. We'll call them R. Whereas the irrational numbers will be right here with the I. And so, that being the case, the square root of 121 is a rational number. Why is it a rational number? Because the square root of 121 is 11. And 11 can be written in the form of an integer divided by another integer. In other words, it can be written as 11 over 1. So that's why the square root of 121 has to be a rational number. Whereas the square root of 2 is an irrational number because we cannot rewrite this number in the form of an integer divided by another integer. Okay? So therefore, it's an irrational number. Whereas pi is also an irrational number. Okay, so an irrational number, once again, is a number that cannot be rewritten as an integer divided by another integer. You cannot rewrite pi in that way. So therefore, pi is an irrational number. If you were looking at its decimal approximation, then the decimal would continue generating random numbers. All right, it would never repeat. And that's another way to define an irrational number, is that the decimal area, the decimal portion of that value never repeats and it never terminates. So that tells you that you are dealing with an irrational number. Whereas all rational numbers will terminate with 0 if you divide the numerator divided by the denominator, or the numbers will repeat. Okay, it will have a repeating decimal part of the answer for those rational numbers. Next, if you're looking at the square root of 50, the square root of 50 is an irrational number. It cannot be written as an integer divided by another integer. But the 1 3/10, yeah, it can. You could write this as 13 divided by 10 because you're dealing with the tens place. So it can be rewritten as an integer divided by another integer. The square root of 10, yeah, that's an irrational number. Thank you. Whereas 3/7 is clearly a rational number because it's already written as an integer divided by another integer. And 27/100ths, that's a rational number. Good job, Raul, with all the answers that you provided, sir. So here we are going to red box our answers, guys. That's exactly what we're going to do, because that is the correct list of rational and irrational numbers from our given list that they have right here. They wanted to label each value as either a rational number or an irrational number. So keep in mind that rational numbers can be rewritten as an integer divided by another integer. Amen, amen. All right, that's problem number 28, guys. Let's move on. There you go with problem number 29. As we are going to deal with some exponential rules now. Oh, yes. So, simplify. That's right. Raul is definitely on fire, Lewis. He is definitely on fire. That's right. So, we have simplify, leave your answer expressed as an exponent. That's right. Raul is enjoying the love that people are giving him for getting everything right. There we go. So let's start out with problem number 29 here with our rules. And already Raul is trying to come down with the answers here. Let's check it out. Here we have 37 raised to the 15th power times 37 raised to the second power. Guys, anytime you are multiplying like bases, as we are in problem number 29, then the equivalent of this is to add the exponents. So you'll keep your base of 37, and then you'll add the 15 plus the 2 to give you a result that is 37 to the 17th power. You'll have 37 raised to the 17th power. Amen, amen. All right. So that is going to be the answer. All right. That's all right there, Raul. That's okay. Raul will get a correct answer coming very soon, very soon. All right, so yeah, so you're going to end up with 37 raised to the 17th power because you add the exponents on those like bases when you're multiplying like bases. So the 15 plus the 2 gives you 37 raised to the 17th power, and done. That's it. Problem number 30, guys. With problem number 30, we have a monomial raised to a power. When you have a situation like this where you only have one term inside the parentheses, guys, raised to an exponent on the outside, you multiply the exponents. That's what you do. So you'll end up with 5 raised to the 7 times 6. That gives you 5 to the 42nd power. And that's it. Yeah. Raul, you got that one right, sir. Good job. And we will red box it. Notice that they have in the directions here to leave your answer expressed as an exponent. So that's why we didn't have to evaluate these very, very, very large numbers is what you would end up with. So they just said to leave it in exponential form. That's right. So here's our answer for problem number 30. 5 raised to the 42nd power. All you had to do, because you had a monomial raised to a power, is multiply all of the exponents. Done and done. Oh, yeah. That's what happened. Here, we can apply the quotient rule for exponents. We have 13 raised to the 8th power divided by 13 to the 3rd power. When you have a situation like this, your like bases are dividing, you subtract the exponents. When you have like bases dividing, subtract the exponents. That's what you do. In other words, this is equivalent to 13 raised to the 8 minus 3. So you'll end up with 13 to the 5th power. This is your answer. There you go. That's right. Accuracy is more important than speed, Raul. Absolutely. Every time. Every time. Raul said that he made a mistake because he was rushing. Yeah, you definitely want to slow down. Okay, you want to slow down, sir, so you can increase that accuracy. Absolutely. Absolutely. So because we had like bases dividing in problem number 31, we subtract the exponents. There it is. Good stuff. Lewis says that he keeps things in mind because he remembers that divide looks like a minus sign. There it is. That is a tip from Lewis. All right. Thank you for chiming in with that, sir. There it is. We got a happy face from Raul again. There we go. Let's keep things popping, guys. We have problem number 29 done, 30 done, and 31 done on this one page. We are on fire, guys. We're just blowing through these problems. We have problem number 32 with a quadratic problem in 8th grade, guys. You guys are dealing with quadratic problems sometimes? Oh, man, that is crazy. Well, let's see what we can do in this problem here, okay? So, with this problem, we have x squared minus 12 equals 13. Let's see how a person could tackle this in 8th grade. What's going on, Angry Hermit? And what I'm going to do, guys, is I'm not going to pull any punches for you guys for problem number 32. We are going to use the square root property appropriately in problem number 32, because I do know for certain that you guys would not have been taught factoring, most likely. All right, so we can't use the difference of squares as an opportunity to solve this problem here. So we're going to see what we can do just using the radicals. All right, taking the square root of both sides. All right, so here we're going to start out, guys, by adding 12 to both sides of the equal sign. So we will begin, all right, by adding 12 to both sides of the equal sign. This will give you x squared equals 25. And because we now, look at Raul with the correct answers. Good job. So now we're going to take the square root of both sides, and I'm going to show you guys the proper way to do this. So for starters, you're going to take the square root of the left side. So we want to solve for x, right? And we are going to take the square root of the right side. However, your radical sign, the square root sign, is always looking for the square root, is looking for the positive root, is what I want to say. It's always looking for the positive root as your answer is, as far as the answer is concerned. All right, so let me go ahead and restate that since I screwed it up. When taking the square root of a value, all right, with the square root sign, the result always needs to be the principal root, aka the positive root. And Tony says my son Noah is doing algebra right now. That is awesome, Tony. So let's go ahead and make sure that he has this example to use in the future. Here, the square root of x squared, guys, is going to give you the absolute value of x, because we have to guarantee that the result will be positive regardless of our values of x. So you end up with the absolute value of x here, whereas the square root of 25 is just 5. Now you're left with an absolute value equation to solve. And remember, the absolute value is the distance to 0. Well, that means that you'll have to set up two equations now. Why? Because we can be 5 places away from 0, to the left of 0 as well as to the right of 0. And that means that our value of x will equal to 5 as well as negative 5. All right, I hate that minus sign. There we go. I hate the negative. Good stuff. So you end up with a result that is 5 or negative 5. And Lewis has the link for the square root property. So therefore, as a solution set, let me see if I can draw a brace today, guys. Oh, that is a decent brace for Mr. Witt, guys. Mr. Witt has that good brace right there. We're going to list our answers in ascending order. Okay, let's see. I got too happy because the right brace. Oh, Lord, the right brace. There we go. That's better. So we end up with negative 5 and 5 for our solutions for problem number 32, showing the square root property, showing that it becomes an absolute value equation, and we put a red box around our answer for problem number 32. That's good. Thank you, Adane, for giving me a thumbs up on that brace. I appreciate it, because you know it's difficult for me to get a good brace going, guys. If you will be so kind as to share the stream on your social media, guys. Also, please like the video. Subscribe to Fort Ben Tutoring if you haven't subscribed already. And also click on that bell icon so you'll be notified when we are live in the future. Amen, amen. Also, if you're able, click on that $sign in your super chat there. That helps you donate to Fort Ben Tutoring to help us with our academic endeavors. And in addition to that, if that doesn't work for you, you can use the link in the description box for that PayPal donation link. Amen, amen. All right, and that is if you're able. Problem number 33, we have solve x cubed minus 6 equals 44, guys. This is a cubic equation. Oh, yeah. So we thought we were getting into dangerous territory with the previous problem, with the quadratic problem. This is a cubic equation. So let's see what we're going to do in order to solve this here problem. Thanks. We're going to go ahead and start by adding 6 to both sides. We still want to isolate that variable. raised to a power. So we have x cubed equals 50. Now, we don't have as many restrictions as when you're trying to take the even root of both sides. In other words, when we were trying to take the square root of both sides, we had to worry about that absolute value situation. You don't have to really worry about that when you're dealing with a cubic equation. No, instead, just take the cube root of both sides, guys. Take the cube root of both sides. You're still responsible for simplifying as much as possible, but it would be the case, in this case, the cube root of 50, it can't be reduced. It can't be reduced. So the answer is just a cube root of 50, and that's it. Yeah, we're going to red box this, Raul. That's exactly what we're going to do. We're going to red box this with Angry Hermit. That's right. That's what we're going to do. Red boxing it. Can't do anything else to this problem, guys. Yes, because see, 50, it doesn't have a factor of 50. That's a perfect cube. You can't simplify this any further. No. No, you can't do anything to that. No, we're going to put it in a red box and keep it moving. That's what we're going to do. Yep. That's what's happening. And so here we have problem number 34. 34, guys. We have 7 times the quantity of 2x minus 2 equals 9x minus 18 plus 5x. That's what we have. And if you didn't know already, I will be getting my arrows popping right now with the distributive property. So we're going to start with 7 times 2x. That gives me 14x. Yes, it does. I have 7 times negative 2. That's negative 14. I'll be bringing down the right side of our equation here, guys. Thank you very much. And now I will be combining like terms. Oh, yeah, Lewis. Angry Hermit is always in the house. Tony says, Noah says red box in the cube root. That's right. Tony's getting clever with his wordplay. So we have 14x minus 14. Oh, I hated the minus sign. We're going to fix the minus sign here. We have to. The minus sign needs to be fixed. On the right side, we have the 9x plus 5x. That gives us 14x. Yes, it does. Minus 18. From here, guys, we are going to subtract 14x to both sides. That's right, Angry Hermit giving Lewis some love here. We have the 14x's that will now cancel out. And guys, turns out that negative 14 equals to negative 18. Is that what they're telling us now? That negative 14 equals to negative 18? Ladies and gentlemen, this is a contradiction. This is a false statement. This is a lie. Therefore, the answer is no solution. It is the null set. It is the empty set. This answer does not exist. So therefore, we will be red boxing it as no solution. Can't be done. Yeah, you can't have a false statement in mathematics. It's just not going to fly. It will not fly. It will not stand, guys. That's right, Fabiola. It doesn't have a solution. It does not. So we went through all of our steps correctly, and we found that in the end, it was a contradiction that they gave us. That negative 14, it definitely doesn't equal to negative 18. That's why we stop at this point and say that it is no solution. Done and done. And on to our next problem, which is number 35. That's right. So for problem number 35, it says to find the total and lateral surface area. Adane says this chat and Mr. Witt is too good. That's right. That's right, Adane, because you're a part of it. That's why the chat is so good. Thanks. Okay? Because you're here. Appreciate you. Problem number 35, guys. It says find the total and lateral surface area for our rectangular prism here. So if you're looking for the total surface area, we'll just call it SA for the total surface area. For a rectangular prism, it is going to be the perimeter of the base times the height plus 2 times the area of the base. And what we'll be calling our bases, guys, is, let's go ahead and see if I can use some coloring here. What we'll call our bases is these areas back here. There we go. We'll call that a base as well as this a base. There we go. How you like that? How you like that drawing that Mr. Witt, went ahead and hooked up real quick? You know what I'm saying? What's going on, Hafer? How you doing? Are you doing an exam review for grade 10? Yes, Hafa. I will be doing an exam for, and generally 10th graders are in geometry here in America. So I will be doing one for Algebra 1. I'll be doing one for geometry, and I'll be doing one for Algebra 2, Hafa, in the near future. Absolutely. So this here is for 8th grade. Then I'll be moving on to Algebra 1, which is for 9th grade, and then Geometry, and then Algebra 2. Tony says Noah wants you to solve x squared plus 2x equals 0. All right, we'll see what I can do today, Tony. I can't promise it, okay? But we're going to definitely finish this problem right here. All right, Noah? There you go. So that being the case, we have our formula for the total surface area as the perimeter of our base, and we're calling our bases these shaded areas here, okay? And times the height of the prism plus 2 times the area of the base. Good stuff. So that being the case, all right, so Hafa says I'm in Algebra 2. Good job, Hafa. Well, Algebra 2 is going to be definitely on my list. It's going to be one of the last final exam reviews that we do this month, all right, or this upcoming this school season, let's just say. All right, so let's go ahead and plug this in. Our perimeter of our rectangular base here, being as though we have dimensions 4 and 5. Remember that the perimeter of a rectangle is 2 times the length plus 2 times the width, right? So we'll have the length of this object being 4 plus our width being 5. And so we'll end up with 8 plus 10 to give us 18. So we'll say that our perimeter is 18 times the height of the prism, which is 7, plus 2 times the area of the base. So the area of a rectangle, just to remind you, is the length times the width. So therefore, plugging in 4 times 5 here, you'll end up with 20 for the area of your base. That's what that big B stands for, the area of the base, which in this case is a rectangle. So you'll end up with 4 times 5 to give you 20 for the area of the base. And this is what we have here. Now we'll be multiplying the 18 times 7. So 18 times 7 is a number I don't know. Let's go ahead and figure it out. We'll say that that's 56, carry that 5. That gives you 126. Is that right, guys? Plus 2 times 20, which is 40. Adding that together gives you 166. And then this would mean that our units are squared in this situation. So our units are squared. It's always to the second power when you're dealing with area, ladies and gentlemen. And then we will red box it. Red boxing it, guys. Now, as far as the lateral surface area is concerned, the formula for the lateral surface area, guys, let me check that out real quick. Let me give you that. The lateral surface area is simply the perimeter times the height. But recall, guys, we already found out this value already because we said that the perimeter is going to be 126. No. We didn't say that. That's the final result. Let's go ahead and go back a step. That the perimeter was 18, the height was 7, and this equals to 126. There we go. So this gives you 126 as far as your lateral area is concerned. So this is going to be units squared. Always to the second power when you're dealing with area, guys. And it looks like some people are helping out Noah and Tony with that answer. There you go. Hafa says, Mr. Witt, you're the best. I'm working on it, Hafa. I am working on it. So for those of you that were here for problem number 35, they asked us for the total surface area. You're going for a rectangular prism. You'll use the formula, the perimeter times the height plus 2 times the area of the base. And we went ahead and found out our perimeter of our shaded bases here. That was 2 times the length plus 2 times the width, and we got 18 as a result. Let's go ahead and put that in a purple circle. All right, for that in-between step. Good job. And now we got those values. We multiplied our 18 times 7 to get 126. We had our 2 times 20, which is 40. We added to get a total area of 166 square units. To answer the question for the lateral surface area, you use the formula, the perimeter times the height. Well, we already did that in our process already. So the perimeter was 18 times our height of 7, gives you 126 units squared, and done. And this is the answer for problem number 35. 5, and done, guys. Let's move on to our next problem, which is problem number 36. Amen, amen. Adane says, your lecturing is so good, it's like having a personal tutor. Absolutely, Adane. I appreciate that, because I too can become your personal tutor. So if you guys want Mr. Witt to tutor you one-on-one, check out our website, tutormemath.net. All right, and set up a one-on-one session with Mr. Witt. There you go. You can have me all to yourself. So we'll have problem number 36, guys. It says find the missing side length of our right triangle here. There you go. So if you're missing a length from a right triangle, guys, you can definitely use what is called the Pythagorean theorem. Yeah. And just to show you here, the Pythagorean theorem, guys, let's go ahead and do a little diagram here. That the Pythagorean theorem is a squared plus b squared equals c squared when the legs of your right triangle are named a and b, and the longest side, the hypotenuse, is called c. The hypotenuse, that c value, will always be opposite the 90-degree angle every single time. And so when you have this scenario, you can use the Pythagorean theorem as we have it in this problem, and we can use that to solve for our missing side. So the c value, in this case the hypotenuse, is our 5 in our problem that we're dealing with for problem number 36. All right, so it doesn't matter which of the values you call a and b in this. Okay, so the legs can just be anything. All right, so bottom line here is that your a value is a leg, the b value is a leg, but your c value is the hypotenuse, and the hypotenuse has to be the longest side of the right triangle. Okay, all right, let's go ahead and clear that out, guys, so you can see it. And now let's use this triangle to solve for x. There you go. That's what we're going to do. So I'm going to say that my first leg is x. So I'll have x squared plus the other leg, which will be 1 squared. And this must equal to 5 squared. Just like that. So when we square these values, 1 times 1 is 1. 5 times 5 is going to be 25, guys. And then in solving for this, we're going to simplify. We're going to isolate the term of the variable by subtracting 1 on both sides. That's exactly what we'll do. And you're going to end up with x squared equals to 24. But you'll need to simplify this. You'll need to take the square root of both sides. All right. So, gotcha. I understand, Noah. And Tony. So Tony says that when Noah's in the chat, that's Tony talking. All right. So he's giving us a protocol for knowing who is who when they get a message from Tony, guys. There you go. All right. So what just happened here? We set up our Pythagorean theorem using a squared plus b squared equals c squared. We plugged in our values from our given triangle with the given lengths of 1, x, and 5. Our legs didn't matter in our setup. So as far as the a and the b is concerned, you could have used 1 for a or x for a. It didn't matter, okay? Because the legs, it doesn't matter which one you label as which. However, the hypotenuse of the triangle must be the c value. So after we plug it in, you're going to go ahead and simplify it, solve for x. We're taking the square root of both sides, and you'll end up with this case, x equals the square root of 24. Now, here's the difference, guys. The difference is that we didn't need the absolute value of this result this time because we're dealing with geometry, okay? We're dealing with a triangle, and our leg length is not going to be negative. So you didn't have to worry about the negative root in this case, all right? So it had to only be a positive answer. It can only be a positive result or 0 when it comes to our lengths of the sides. That's what's up. So that being the case, you'll need to simplify this by showing that the largest perfect square within 24 is 4. So we can break up that square root of 24 into 4 times 6 because 4 is the largest factor of 24 that is also a perfect square. Okay? So then take the square root of 4, take the square root of 4, and you'll get 2 times the square root of 6, and this is your answer simplified. There it is. And if you need to see more examples of problems like this where we are simplifying square roots, you can check out that video called Simplifying Square Roots. Yeah, you can do that. Now, I still need to make a video, guys, on the Pythagorean theorem. So good thing we had a problem like this in number 36, because here you have an example of solving a problem using the Pythagorean theorem. I need to make an entire video just on that, guys. So that'll be coming down the pipeline eventually. All right, that was problem number 36. We're on to problem number 37. That's what's going on. So with problem number 37, guys, it says, how much ice cream would it take to fill a cone with radius 5 centimeters and a height of 12 centimeters? So we're dealing with a cone situation here now, right? And it's an ice cream cone. So this drawing is about to be jacked up, guys, just to warn you. Just to warn you that the drawing is going to be a little jacked up. It's going to be jacked up. It's okay. It's okay. It's okay. So here we have a cone. There we go. Yeah, I was doing good until I got to that radius there. I don't know why the radius was the worst part of this graph, but it was for some reason. I think because I was going to try to go with a dashed line for the radius, but I shouldn't have. I should have just did it like that. Yeah. There we go. That's better. There you go. What y'all think, guys? Pretty good on the cone? I think I did pretty good on the cone. I'm thinking that the cone was okay. The cone is okay. So let's go ahead and use this diagram to label. All right, let's do that. So once again, we're dealing with an ice cream cone, so therefore a cone. All right. Lewis has the link for the simplifying square roots. Good job, Lewis. Thank you. We have a radius that is 5 centimeters. All right. That was supposed to be centimeters. That's better. That's a little better. No. It's ugly. There we go. 5 centimeters. Thank you. And we have a height. Let's go ahead and get that height in play. There we go. All right. And we have a height of the cone, which is 12 centimeters. 12 centimeters. So we're dealing with a radius of 5 centimeters. We're dealing with a height of 12 centimeters, guys. And because we're looking for the volume of this cone in order to solve the problem, we'll be using the formula volume equals to 1/3 the area of the base times the height. So in this case, the area of our circular base is going to be pi r squared times the height of the cone. This is a formula that we can use to solve our problem right here. Amen, amen. So let's go ahead and plug in these values. We'll have 1/3 pi, which we'll say is going to be approximately 3 1400ths. That's right. That's what 8th graders would use. And so our radius is 5 squared, and then our height here is 12. So this is what I have thus far, guys. From here, we'll have 1/3 times 3 1400ths times 25 times 12. We have that. I hated that too. This is better too. There we go. Then taking 1/3 of 12, guys, is what I'm going to do next. Taking 1/3 of 12, 3 goes into itself once, 3 goes into 12 4 times, and then multiplying 4 times 25 gives us 100. So we'll have 100 times 3 1400ths. And guys, multiplying the 3 1400ths by 100, we'll just simply move that decimal over 2 places to the right. So move the decimal over two places to the right, you'll end up with 314 and done. And the centimeters will be cubed, guys. What am I doing with that black box? Get that black box out of here. We need a red box for this answer. So we end up with 314 cubic centimeters. How do you like that, guys? The calculations with no calculator. That's right. The calculations with no calculator for finding the volume of the cone. Oh, yeah. That was pretty good. I don't know about you guys. I knew it was going to be a good problem because that diagram right there was pretty decent. I'm just saying. It's not every day you get a good cone. All right? So, I think that diagram was pretty cool. I'm pretty proud of that cone. Just saying. Proud of the cone. Here's another cone. We have problem number 38. It says, what is the slant height of the cone? That's right. Adane is already supporting. Talking about, thank you, Mr. Witt. I like it. Appreciate that. So for problem number 38, it says, what is the slant height of the cone? The slant height that they're referring to, guys, is where this value of x is. This line right here. So actually, you can go ahead and just look at this diagram and only focus on the right triangle that you'll find right here, because it is labeled as X, the height is 9, and because we're dealing with a cone and it's a 90-degree angle, that's going to confirm that that's the definite center, that it's hitting the center of that cone, of this right cone here. And so therefore, half of the diameter is the radius is 12. All right. So it looks like with us having 2 out of 3 sides of a right triangle that we will once again use the Pythagorean theorem in order to solve this, guys. Remember? So that Pythagorean theorem once again is a squared plus b squared equals c squared. So anytime you have a right triangle and you have 2 out of the 3 sides of that right triangle, you can use those 2 sides to find out the third side using the Pythagorean theorem. It's pretty cool. Yeah. So that is how to properly use the Pythagorean theorem. So remember earlier, guys, I told you that it didn't matter how we label our legs as long as the hypotenuse is the C value here. So we'll say that the 12 will be my A value. So we'll call that 12 squared plus our B value, which is 9 squared. And this has to equal to X squared here. There you go. That's what's up. And then continuing this process, 12 squared, that 12 times 12 gives you 144. The 9 times 9 gives you 81. Yes, it does. Then we're going to add these two values together, 144 plus 81. Isn't this 225, guys? Is that not 225? We'll at this point, we're going to, thank you, Fabiola, appreciate it. At this point, we have 225 equals to x squared, but we still need to solve for x, Fabiola. So that means that we'll be taking the square root of 225, and I hate it. I hated the square root sign. So there you go. I think that's a better square root sign. I had to have the best square root sign, guys, for you guys. There you go. So now we'll be taking the square root of both sides, and so the square root of 225 is 15. And once again, because we're dealing with a side length, all right, we only had to be concerned with the positive answer. So therefore, there's no need to have the absolute value of x squared there because we're only concerned about the positive root only in this case. So our answer for x can only be positive. So therefore, we didn't have that concern. So your answer here is going to be 15. And that's it. 15 units. No problem, Fabiola. We're here to correct our future mistakes. That's right. So you want to make your mistakes now so you won't make mistakes in the future, Fabiola. We're going to be making a better you, a more accurate you. That's right. So we have problem number 38 is done, guys. So it turns out that in order to solve for the slant height of this cone, we needed to use the Pythagorean theorem. That's right, the Pythagorean theorem. That's what we used. All right, so Pythagorean. Let's go ahead and write this out here for those that need to know. That's an ugly R. There we go. Pythagorean theorem. That's what was utilized to solve this problem. That's right. That's right, Lewis. So you could have used that ratio of 345 in order to solve that problem as well. Absolutely. Absolutely. So that's problem number 38. That was a good example, guys. That was good. I think that example was good. There you go. Problem number 39 is in the house, guys. With 39, it asks us to find the volume of the sphere. Find the volume of the sphere. So with this particular problem, guys, we're going to be utilizing the formula 4/3 pi r cubed to find the volume of a sphere. This is the formula for that. So when you're asked to find the volume of a sphere, you need the formula 4/3 pi r cubed. There it is. That's what's up. And now let's go ahead and plug in some values here. We'll have 4/3 times, and we're going to use pi as an approximated value of 3 1400ths. And then our radius here is 2. So you'll have 2 cubed. Oh, yeah. From here, you'll have 4/3 times the quantity of 3 1400ths. 2 to the third power is 2 times 2 times 2, which is 8. And once we have this, guys, we're going to then multiply this out and find out our results here. So let's go ahead and start by multiplying the 3 1400ths times the 8. Okay, that's going to be the safest bet for me for now. So we'll have 3 1400ths times 8. That's going to give me 32. I'm going to carry that 3 there. That's going to be 8 times 1 is 8, plus the 3 is 11. Bring down the 1, carry the 1. 8 times 3 is 24 plus the 1 gives me 25. Move that decimal over twice. You end up with 25 and 12/100ths. There you go. All right. Now from here, let's go ahead and multiply by 4, then divide by 3. That's what I'm going to do. So let's multiply the 25 and 12/100ths by 4. All right, and that's from the numerator, multiplying that numerator 4/3. If we were to say that the 25 and 12/100ths was over 1 and multiplying straight across, you would then multiply 4 times 25 and 12/100ths, then divide by 3. So that's the process that I'm using right now. So multiplying this out, I have 8, 4, that's 20, carry the 2 there, you'll end up with 10. Move the decimal over twice, you'll end up with 148/100ths. And so finally, we need to divide this value by 3 to get our result here. So let's say that we'll be rounding to the nearest hundredths place in this case. You'll have 3 going into 100 and 48/100ths, just like that. So we'll have 3 going into 10 3 times. That gives me 9. Subtract, bring down to 1 and a 0. 3 goes into 10 3 times. Thank you. That'll be 9. Subtract, bring down to 1 to 4. 3 goes into 14. That'll be 4 times. That'll be a 12. Subtract, bring down to 2 and 8. Okay. Then we have 3 going into 28. That'll be 9 times, right? And then that'll be 27. So you'll have 28 minus 27. You'll have a 1. You can add a 0 there, guys. And then you'll have a 3. So I said that we were going to round to the nearest hundredths place. So that's why I needed to go to the thousandths place in my long division. So rounding this to the nearest hundredths place, we'll have 33 and 49/100ths. And this is going to be cubic inches. Since we're dealing with volume, your unit of measurement will always be to the 3rd power. And so now we are going to red box it. And that is our answer for problem number 39, guys. That is the answer. Yeah. So we just did the volume of a sphere. Something that you guys should definitely encounter on your final exams for 8th grade. Amen, amen. So next up, we're looking at problem number 40. And in problem number 40, it says to find the distance between the points 3, 4, and 7, 6. Well, this will require, guys, the distance formula. And the distance formula is as follows. It's going to be x2 minus x1 squared plus y2 minus y1 squared. So what you're looking at right now is the distance formula for finding the distance between 2 points. I would suggest that you start out by labeling your points first. So we're going to label this first point as x1, y1. We'll be labeling the second point as x2, y2. All right, just like this. And then from here, we'll plug in our values. So plugging in our values here, plugging in the values, we'll have x2 is 7 minus our x1 value, which is 3. This is going to be squared, plus y2, which is 6, minus our y1 value, which is 4, and we're going to square that. We'll find the differences within the parentheses. So we know that 7 minus 3 is 4 squared. We have 6 minus 4, which is going to be 2 squared. All right. Good job, Noah, on getting that previous answer. Good stuff. So here we're going to have the square root of 16 plus 4 to give you the square root of 20. Now, just like I showed you before, we can simplify this square root of 20 because there is a perfect square within 20. So the largest perfect square within 20 is 4. So we can expand this into the square root of 4 times 5. Now you'll simply take the square root of 4, which is 2, which will come on the outside of the square root sign, and what remains stays inside. So you'll have 2 times the square root of 5 as your answer, and done, guys. This is the length between the 2 points 3, 4, and 7, 6. Done and done. And that was using the distance formula. That was problem number 40. Amen, amen, guys. Moving on to problem number 41. All right, so check this out, guys. We have this problem here where it says which relation is a function. Which relation is a function? Now, a relation, guys, is just a set of ordered pairs. A set of ordered pairs. However, a function is a set of ordered pairs where none of the x values repeat. Okay, so your x values can't repeat in order for you to have a function. But a relation is just a group of ordered pairs. So in other words, a function is a relation where the x values don't repeat. That's what we're looking for. That's what we need. So we have choices A, B, C, and D. Which of these guys, which of these choices is a function? So if we're looking at A, if we just focus only on the x values here, we'll have 0, 1, 2, 3, and 3. Well, this is not a function, guys, because those x values are repeating right here. We can't have the x values repeat. So therefore, A is not a function. Looking at B, we're looking at x values of 0, 1, 2, 2, and 3. So in this example, in this problem, in this choice, the 2's repeat. We can't have repeating x values, guys. So therefore, B's not the answer. If I look at C, we have x values that are 0, 1, 2, 3, and 4. Well, see, that looks good because all of the x values are different. So I'm going to say that this is a function. Whereas if we look at D, guys, D, we have 0, 1, 0, 4, and 3. So once again, we have repeating x values for D. So D is not the answer. So our choice here has to be C. Good job, Lewis. Good job. The answer is C. Absolutely. Absolutely. We got a black box on C. There you go, guys. So that's problem 41. That is being able to identify a function from a group of relations. Oh, yeah. That was problem number 41. Okay. So I believe, guys, that we're going to wrap up with problem number 42. With problem number 42, it says to simplify the expression 3 times the square root of 15 minus 7 times the square root of 15. Well, in a situation like this, guys, you can only add or subtract radicals if the radicals are identical to each other. And that's exactly what we're looking at. The square root of 15 and square root of 15 here, they are the exact same square root. So we can subtract these. We can combine these. So that means that we have 3 minus 7, which gives us negative 4 times the square root of 15, and done. 3 minus 7 gives you negative 4, and you keep that same square root sign along with those terms that made like terms when we had the exact same radicals, and you just take the difference of the coefficients, the numbers in front of the square root signs. So you have 3 minus 7, that gives you negative 4. So we end up with a result of negative 4 times the square root of 15. Done and done with a red box, ladies and gentlemen. So this is Mr. Witt with Fort Bend Tutoring. This was part 2 of the 8th grade mathematics final exam review. I appreciate you guys chiming in, checking in with me today. Tony, Noah, Lewis, Fabiola, Adane, Hafer was in the house. We also had Angry Hermit in the house, holding it down. Raul was in the house. All right. And I appreciate you guys. Stephen Chan was in the house. Chosen Creeper was in the house. Saymon was in the house. And Tameo was in the house. So you guys please like, rate, comment, and subscribe, guys. And as always, this is Mr. Witt signing off with Mr. Witt and Fort Bend Tutoring. Peace. Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.